So step by step, the design of a conjoint study. First step is to identify the attributes. Typically, conjoint analysis is done with attributes. It's also possible to use benefits, that is, the values that people are getting from those attributes, or more general or vague sort of positioning points. These are kind of descriptors of the product that are more general rather than objective or discrete attribute levels. Where do those attributes come from? Well, they come from manager experience, from exploratory studies, clearly with a new product, some sort of exploration of how consumers are thinking about the product and what things they're paying attention to or what things they're looking for would be appropriate. And from past studies. Surveys typically will ask people about attributes and include an other category, and over time increasing mention of other attributes result in recognition that those should be included. Next, identify the levels of each attribute. This is an important point. Price is almost always an important attribute, but then the question is all level of price. What possible price points? So understanding of cost and value would be necessary to identify by price extreme, and some positioning relative to competitors probably dictate the meaning prices. Lies for quality engines, some understanding of the necessary inputs and the level of quality people are willing to pay for would be necessary. It's also important for the levels, again, understand language that consumers use. How do you describe intervening levels of workmanship or reliability? Step is to consider reducing the number of alternatives presented. Remember that the total number of configurations goes up as a product of the number of levels of attributes. So a brand that's described with 6 attributes, 4 levels of each, has hundreds and hundreds and hundreds of product configurations. Conjoint analysis ideally gets a rating or a ranking or some evaluative judgment on every one of those configurations. And researchers can't expect participants to go through hundreds or thousands of product configurations and give meaningful evaluations. So that number could greatly reduce several ways. The typical approach is to produce what's called an orthogonal array of alternatives. And an orthogonal array means that the analysis will yield only main effects of attribute levels and no interaction effects. So if you think of this in terms of multiple regression, if there are 3 independent variables, you beta weight for each of the three independent variables, but no beta weights for interactions between pairs of independent variables, no beta weight for the three-way interaction of all 3. In most cases, that's sufficient. Most of the evidence suggests that it's unusual for consumers to evaluate products in terms of interactions. There are exceptions. For example, when people think about cars, they may think about high-performance cars, low-performance cars, high-mileage cars, and low-mileage cars, but they may think about low mileage the performance dimension differently for low mileage cars than for high mileage cars. But those are the exceptions. A second alternative is to do multiple studies. So if there are, say, 500 product configurations to be evaluated, one could have a sample of people evaluate 100 of them, and then 4 other samples evaluate other groups of 100. That sort of research design is complicated because, I have different people doing the same measures. So an additional source of variance across those 5 groups. Most software that does conjoint analysis has a feature that will identify whether people are making complex evaluations that require the measure of interaction effects. This is called smart software for conjoint analysis, and as the data are being collected, if they're entered, for example, if it's being done on a computer, those analyses can be done virtually instantaneously, and they will produce results that show what sorts of combinations need to be offered. And in fact, the software can be loaded with every possible combination, and it will automatically present the necessary combinations to estimate whatever models seem to be showing up in the results. So we've got the attributes identified. We know which levels to include. We've identified how many alternatives and which alternatives to present. Then we need to, the next step is to decide how to present those stimuli. The most common is text-based. A few words describe the product. In some cases, there may be pictures. In rare cases, even mock-ups. Now, clearly, with mock-ups, the search gets complicated, requires people to be picking things up, looking at them, and so that further limits the number of configurations that can be presented. Then choose the sample and the site, the same we would for any research. Next is to decide on the criterion. We're asking people to make judgments. Usually, judgments are preference. Do you which of these do you like best? Which of these you prefer? Or intention to buy? How likely to buy this? Or if you had these to choose from, which would you buy? And finally, the specific measure within rating. How much prefer this, or how likely are you to it? Rank these in order of preference. Rank these in order of intention to buy. Or preference. If you have these two, which you prefer? If you had two, which would you buy? Let me use the blouse example to illustrate some of those points. So a blouse might be conceptualized in terms of style, fiber, and origin, where it's made. So the style has two levels. It's either classic or trendy. The fiber at also levels. It could be cotton or a cotton blend, say 60% cotton, 30% polyester. The price might be relative to the average price, $10 above average, or $10 below, so 3 levels of price. And the origin, let's say made in China or made in the USA. So the stimuli that would be presented and the measures that would be taken, and here I'm using preference as the measure. A preference approach would be to present a large number of choices, such as, which would you prefer? A blouse with classic style, all cotton, $10 below the average price, and made in China, or a blouse with classic style, a cotton blend, average price, and made in the USA. I notice that those two configurations differ, in this case, on more than one attribute. And it's, in some cases, they may differ on all the attributes. And a large number of choices would be made to get enough data to estimate the utility of each attribute. So that's a preference approach. A ranking approach would be to present all the configuration, usually on cards. So an index card, for example, with the description printed. It could include a picture. And ask the respondent to separate those into smaller groups, typically into 3 groups, with instructions to create a group that you like very much, another group that you like a little, and another group that you don't like much at all. And then to go back through those groups and to rank those in order. And that works for total sizes of maybe 100 configurations or even 200 configurations, where people can get down into smaller groups of 30 to 50 and do the individual ranking in a reasonable way. And a third approach is to ask for ratings. That is to rate each configuration on an evaluated scale. How much do you like this configuration on a 1 to 7 scale? Now, these approaches are in ascending order of ease for participants. Consumers find it easy to make preference judgments. I like this better than that. It's more difficult, but relatively easy to make rankings. I like this better than that, better than that, better than that. And it's most difficult to rate things. Rating is done independently, so there's no comparison involved, and there's a lot of error going from one to the next. Unfortunately, the statistical value of measures runs it in the opposite direction. Conjoint analysis be done as mentioned earlier for 3 purposes. One is an aggregate analysis of the attribute level desirability and attribute importance. So aggregate analysis because though the computations are individually, it's fairly of interest to know what one individual's preferences are. We want some way to general across a group. And the attributable desirability is, of course, the weights for each level of an attribute, and then we can use those to impute overall importance to attribute. So this doing this are to compare utility weights for each individual. And you can think of that as was rated with the locker room or the health club example. Each individual essentially ranking, offering some overall judgment, and the analysis produces utility weights for that person. And then those utility weights can be aggregated. Because we have many attributes with many levels, that analysis typically is done with regression. So a regression equation is produced in which we get a beta weight for each attribute level. So we do that for each person, and then we aggregate those individual scores, and we just simply take the mean for each utility weight across people. We can do that for the whole sample, or I'll go into in the next slide, we can look at segments of people. And in fact, we can create segments from those utility scores. Then we can look at those average utility weights for attribute level desirability. So we can say that this level of an attribute is more valuable than all the other levels of that attribute. And we can also look across attributes. So we can say that people are willing to trade off $100 in price savings, for example, or they're willing to give up $100 in price in order to get a 50% improvement in speed. So one of the beauties of conjoint analysis is that it allows comparisons across attributes on the same metric. And then step 4, we can look at the range of utility weights within attribute, that is across levels of the same attribute, as an indication of attribute importance. So if utility weights range from 0.1 to 0.9 on one attribute, that means that if we choose the best level of attribute, we get 0.9 units of utility, and if we choose the worst, we don't get 0.1, so we get a range 0.8. That makes that attribute considerably more important than another attribute where the range only from 0.5 to 0.6, or 0.8 to 0.9. Because that second attribute, if we chose the best level or the worst level, it's only a matter of a tenth of a point utility. Now, you need to be careful talking about the importance level in terms of range of utility because it's sensitive to the range of attribute levels. It's very easy to have a high range of attribute levels if the attribute levels that are measured are very different. So a second type of analysis, second application of conjoint analysis, is segmentation analysis, using those utility weights from conjoint analysis to identify segments. So the first step is the same, to compute the utility weights for each individual. The next is to analyze those utility weights, identify similarities. So people who attach the same value or the same importance to the same group of attribute levels belong together. Typically that's done with cluster analysis. Cluster analysis is sort of a combination of analysis, variance, and multiple regression. It groups scores in such a way as to minimize the variance in those scores. So if you knew which cluster a person was involved in, then would give you some indication as to what that person's scores were. And the result of that is benefit citation. So if you started with 500 people and you identified three segments, the across those three segments would be that they wanted different attribute levels, and they wanted different attribute levels because those attributes were presumed to relate different benefits. If one were to say the automobile, for example, one would find probably find of people who attached utility to economy and less utility to performance. And there would be a group of people that was the opposite, more utility performance and less utility to economy. And there might be enough people who attach relatively modest utility to both those, but utility to safety, and so on. Now, the third application of conjoint analysis is to scenario simulations, to identify preferences for products among scenarios, different products available. First step is to compute the utility weights for each individual. Second step is to aggregate across individuals, either for the entire sample or segments within the sample. And then to use those utility weights to compute the overall product utility for any configuration. So simply adding the utility weight for each attribute level up for the whole product. And then to predict product preference from those individual product utilities. So if a consumer is looking at three products and we knew the utility weight for each attribute level, and we knew what the attributes were in each product, then we should be able to predict which product would be preferred. So if a firm were introducing a new product into a marketplace that was dominated by 3 existing products, then the researcher could estimate the utility of all the attribute levels involved and use that to come up with an overall product utility for 3 different products and for the new proposed product, and could from those estimates come up with a projected market share for the new product. Now, how do we predict product preference in the individual product abilities? Well, there are 2 approaches. One is the first choice rule. And according to that, individual will opt for his highest utility. So individual 1, we have his utility for each attribute level, and we have therefore his perceived utility of the product, and we would estimate he would pick the product for which utility is highest. And then that would be different for every individual, because every person might have different utility weights for the different levels. We simply count how many people prefer product A, how many prefer product, and so on. The second approach presumes there's a discrete choice. There's probability of change. It's called the share of preference rule. So we say that each individual has a probability of purchasing each product, and that's equal to the share of utilities. So if I'm looking at 3 products, and I say that product A has a total utility of 8, and product B has a total utility of 2, and product C has a total, let me back up. Let's say that product A has a total utility of 7, and product B has a total utility of 2, and product C has a total utility of 1, right? So the first choice rule, say I would definitely purchase product A. The share preference rule says that I'm pretty likely to purchase product A, but it would only be a 70% probability. The utility for product A is 7. Total of probabilities is 7, 2 plus 1. So I'll be 70 likely to product A, 20 likely to product B, and 10% likely to purchase product C. And to estimate the market share overall, we would the average of the shares of preference overall.